Bismillahirrahmanirrahim. Assalamu alaikum grade 6. Hope so you all are well by the grace of Allah Almighty. Students, in our previous lecture we have completed exercise 2b and question number 5, 6 and 7 and also multiple choice of unit number 2. Let's welcome to the intricate world of factors and multiples. This world was let open to mathematicians by the invention of Arabic system of numerals. As we know that the Arabic numerals are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So we are going to start our unit number 3, that is factors and multiples. Let's start what is a factor and what is a multiple. Here is the definition given of a factor, that is one number is a factor of another number if it divides into that number with no remainder, which means that a number that divides another number completely without leaving any remainder is a factor of that number. Here is the example given below. As we can see here, 2 is a factor of 16. It means that 16 is completely divisible by 2 and leaves no remainder. So we can say that 2 is a factor of 16, which means that a multiple of a number is a number obtained by multiplying that number by any natural number. Here is the example given, that is 16 is a multiple of 2 and also 21 is a multiple of 3, as 3 sevens are 21. So let's see combine example given below, that is when 5 multiplied by 4 the answer is 20. As we can see here, the numbers 5 and 4 are the factors of 20 and 20 is a multiple of 5 and 4. This was all about factors and multiples. Let's see some more examples to understand the concept of factor and multiple. We can see here 2 is multiplying to 3 and the answer is 6. The number 2 and 3 both are the factors of 6 and also 6 is a multiple of 2 and 3. Now let's see some more examples of factors 12 and 30. The above mentioned are the factors of 12, and that is if we multiply by 1 and 12, then the answer is 12. And if we multiply 2 and 6, the answer is 12. By multiplying 3 and 4, the answer is 12. So 1, 2, 3, 4, 6 and 12 are the factors of 12. As we know that the factors of any number is itself and 1 also. Here are the factors of 12. 1, 2, 3, 4, 6 and 12. Let's move to the factors of 30, that is 1 multiplied by 30 is equal to 30 and 2 multiplied by 15 is also 30. 3 multiplied by 10 is equal to 30 and last one is 5 multiplied by 6 is equal to 30. We can see that the factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 30. We will write the factors of 30 in ascending order as here are mentioned. Now students, let's have a formula for dividend, which is equal to divisor multiplied by quotient plus remainder, as we can see here. And the example related to this formula is just given above. We can see that is 20 is equal to 2 multiplied by 7 plus 6. Here 20 is dividend, 2 is divisor, 7 is quotient and 6 is remainder. Now student, in the world where every natural number can be generated by multiplying 2 or more of the basic numerals that are 0 to 9, there some exist few numbers which do not obey this rule, that are prime numbers. So let's see, here is the definition of prime number. So prime number is a number that has only two factors, itself and 1, which means that prime number cannot be expressed as a multiple of any number other than 1 and itself. For example, 7 is a prime because the only number that will divide it into evenly are 1 and 7. It cannot be divisible by any number without 1 or itself, which shows that 7 is a prime number. And the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19 and so on. Students, these are the numbers which are divisible by their self and the digit 1. Now see a concept about composite number. Composite number, a number that has more than two factors. We can see here the definition. And now next move towards the example, that is the number 8. The factors of 8 are 1, 2, 4 and 8. We can see here the factors of 8 are more than 2. So this is a composite number. Here are the examples of composite numbers. Except prime numbers, all the numbers are composite numbers. Now let's have an example number 1, and the example is 8 a factor of 256? And the solution is divide 256 by 8. So let's divide 256 by 8 by dividing and solving. 8 3s are 24 as we know, and by subtracting 4 from 5 the answer is 1 and 6 as it is. 8 2s are 16, and by solving 16 minus 16 is equal to 0, which means that there is no remainder left. And also 256 is equal to 8 multiplied by 32, which shows that 8 and 32 are the factors of 256 as it leaves no remainder. 8 is a factor of 256 and 256 is divisible by 8. This is what we can find the factors by division method of any number. Students, to practice of example number 2 and 3 by yourself, as I have explained all about factors. Let's see, here is a note that is about perfect numbers. A perfect number is a number whose factors other than the number itself, when summed, total the number itself. It means that perfect number is a number whose factors when we add up except that number, then the total is the number itself. For example, the lowest perfect number is 6, as its factor except for 6 are 1, 2, 3. We know that the factors of 6 are 1, 2, 3 and 6, but in this method we will not include the number 6 and just sum up the other factors that are 1, 2, 3. So adding up 1, 2, 3, the answer is equal to 6, and the answer is that number whose factors these are. Students, perfect numbers are very rare. Can you find at least one other? So take some time to find at least one other perfect number. Now move to the tests of divisibility. The following table gives the rules to test the divisibility of some numbers. Here is mentioned that the digit 2 is divisible by the number only if the digit in the units place of the number is 0, 2, 4, 6 or 8. It means that in any number, if these numbers 0, 2, 4, 6 and onward even numbers are present in the unit place, then that number would be divisible by 2. For example, I have written here 24. We can see that in the unit place the digit is 4, which shows that the number is divisible by 2. 3. The sum of the digits of the number is divisible by 3, as if we can see here, suppose the number is 27, and now adding up the digits of this number, that would be 2 plus 7 is equal to 9. So we can see that the 9 is divisible by 3. Next one is the digit 4 is divisible by the number if the number formed by the last two digits of the number is a multiple of 4. It means that if the last two digits of any number are multiple of 4, then that number would be divisible by 4. For example, if I can write here it as 124, we can see that the last two digits are the multiples of 4. So this number is divisible by 4. Next one is the digit 5, and this is divisible by the number only if the number ends with either 0 or 5. It means that if in unit place the number is 0 or 5, then that number would be divisible by 5. Next one is the digit 6 is divisible by the number if the number is divisible by 2 and the sum of the digits of the number is multiple of 3. It means that the first condition is the number is divisible by 2. Let's have an example of the number 54. We can see that in the unit place the digit is 4, which shows that the number is a multiple of 2 and also divisible by 2. And second condition is that the sum of the digits of the number is a multiple of 3. Either the sum of these numbers is a multiple of 3. Let's say 5 plus 4 is equal to 9. Yes, 9 is a multiple of 3. So it means that this number is divisible by 6. Next one is 8. 8 is divisible by the number only that if the number formed by the last 3 digits is a multiple of 8. It means that if the last 3 digits multiple of 8, then that number would be divisible by 8. Next one is 9. The sum of the digits of the number is a multiple of 9. Let's take an example, that is 81 is equal to, if we take sum of these digits 8 plus 1, that would become 9. So it means that this number is divisible by 9. Next one is 10. 10 is divisible by the number if the digit in the units place of the number is 0. If 0 is present in the unit place, then that number would be divisible by 10. Next one is 11. 11 is divisible by the number if and only if the differences between the sum of the alternate digits of the number is 0 or a multiple of 11. Either the differences of the sum of the alternate digits is 0 or a multiple of 11, then that number would be divisible by 11. Now let's see an example to understand this concept. And the example is the number 478,301,967 divisible by 11? First of all, let's see alternate numbers that are 4, 8, 0, 9 and 7 by skipping one number. And the second alternate numbers are 7, 3, 1 and 6. So next one is the sum of the digits in the odd places. As we can see here are 4, 8, 0, 9 and 7, and their sum is equal to 28. And sum of the digits in the even places are 7, 3, 1 and 6, and their sums is equal to 17. Now we know that their differences if is equal to 0 or 11, then it means that this number would be divisible by 11. So let's see their differences, that is 28 minus 17 is equal to 11. So we know that 11 is a multiple of 11, and this shows that the number is divisible by 11. And students, the last one is 25, that is the number formed by the last two digits of the number is divisible by 25. For example, if the number is 450, we can see here the last two digits are the multiples of 25, as 25 twos are 50, which means that this number is divisible by 25. Student, this was all about how can we find the given number is either divisible by 2, 3, 4, 5 and so on. Let's take an example related to the rules we just have studied now. And the example is part number 1 of example number 4 is 3564 divisible by 4. So we can see here that the last two digits are the multiples of 4. Hence the last two digits from 64, which is divisible by 4. So we can say it as 3564 is divisible by 4. Part number 2 is 3242 divisible by 3, and the solution is we can add the digits to find either it is divisible by 3 or not. So add the digits of 3242, we get 3 plus 2 plus 4 plus 2 and is equal to 11, and this digit is not the multiple of 3. Hence 3242 is not divisible by 3. Students, here are more examples mentioned. Do practice of that examples according to the rules given. Now let's see an example of multiplication. That is example number 5 and part number 1, as we have already studied the definition of multiples. Let's see here for less than 25. So as we know that the multiples of 4 less than 25 are when 4 multiplied to 1, that is 1. 4 multiplied by 2, that is 8. 4 multiplied 3 is equal to 12. 4 multiplied by 4 is equal to 16. 4 multiplied by 5 is equal to 20, and 4 multiplied by 6 is equal to 24. We can see that by multiplying 4 to 6, the answer is 24, and it is also less than 25, which means that the multiples of 4 less than 25 are 4, 8, 12, 16, 20 and 24. This is what how can we find multiples of any number less than or greater than according to the given condition provided. Here is the part number 2, that is 9 less than 50. So we have to find multiples of 9 less than 50. As we know that the multiples of 9 less than 50 are 9, 18, 27, 36 and 45. If we multiply 9 to 6, the answer is 54, that is greater than 50, which shows that the multiples of 9 less than 50 are 9, 18, 27, 36 and 45. Now let's start exercise 3a and question number 1, that is fill in the blanks. Part number 1 is 135 is equal to 12 multiplied by dash plus dash. As we can see here, 135 is dividend, and we have also studied the formula about dividend, that is equal to divisor multiplied by quotient plus remainder. Here 12 is divisor. So let's solve and see what are the numbers should be in these blanks. Here we can see that 135 is dividend and 12 is divisor. By solving 12 ones are 12 and now subtract 2 from 3. The answer is 1 and 5 is as it is. Now 12 ones are 12 and by subtracting the answer is 3. We can see here the 3 is remainder and 11 is quotient. Now I am writing here 11 is the quotient and 3 is remainder. Move towards the part number 2. That is 219 is equal to 23 multiplied by dash plus dash. As we can see here 219 is the dividend and 23 is divisor. By solving it, the quotient will be 9 and the remainder will be 12. So students, solve it yourself. Part number 3 is 487 is equal to 37 multiplied by dash plus dash. As we can see here 487 is dividend, 37 is divisor, and by solving it the quotient is 13 and remainder is 6. So also solve it yourself. Next question is question number 2. State whether the following are true or false. Number 1 is every natural number is a multiple of itself. As we know that every natural number is a multiple of itself, and that's why this statement is true. Part number 2 is 1 is a factor of every natural number. And yes, 1 is also a factor of every natural number. In fact, of every number, 1 is a factor of that number. So this statement is also true. 3 is multiples of 12 are all multiples of 9. Students, we know that the multiples of 9 are not all the multiples of 12, which shows that this statement is false. Fourth one is multiples of 8 are all multiples of both 2 and 4. As we know that in multiples 2 and 4 there exist 8. And if we see the second multiple of 8, that is 16. And 16 is also a multiple of 2 and 4. Which shows that this statement is true. Question number 3 is write the first 5 multiples of part number 1 is 17. We have to write the first 5 multiples of 17. So let's see. Here we can see that the solution is first 5 multiples of 17 are. By multiplying 17 to 1, the answer is 17. This is the first multiple of 17. Second multiple would be 34. Third multiple is 51 and fourth multiple is 68 and fifth multiple is 85. Which means that 17, 34, 51, 68 and 85 are the first 5 multiples of 17. So let's find the multiples of 23. First 5 multiples of 23 are, by multiplying 23 to 1, the answer is 23. This is the first multiple of 23. Second multiple of 23 is 46. Third multiple of 23 is 69. Fourth multiple of 23 is 92. Fifth multiple of 23 is 115. So 23, 46, 69, 92 and 115 are the first 5 multiples of 23. Now let's find first 5 multiples of 47. The first 5 multiples of 47 are, first multiple as we can see here, that is 47. Second multiple, by multiplying it to 47, the answer is 94. Third multiple is 141. Fourth multiple is 188 and fifth multiple of 47 is 235. Hence 47, 94, 141, 188 and 235 are the first 5 multiples of 47. Question number 4 is list the multiples of 7 between 10 and 40. In this question we have to find the multiples of 7 between 10 and 40. Here is the solution of multiples of 7 between 10 and 40. As the condition is given that the multiples of 7 should be greater than 10. So we know that the multiple of 7 greater than 10 is 14, 21, 28, 35. And second condition is given the multiples of 7 should be less than 40, and that is 35. So the multiples of 7 between 10 and 40 are 14, 21, 28 and 35. Question number 5 is list the multiples of 11 less than 50. And the solution is multiples of 11 less than 50 are, as we know that less than 50 multiples of 11 are 11, 22, 33, 44. These are the multiples of 11 less than 50. Okay students, understood and learn all the concepts, and also do practice of exercise 3a question number 1, 2, 3, 4 and 5. Okay, stay home, stay safe. Allah Hafiz.